Hello everyone. In this part of the video, we will solve a few problems on viscosity. So as you can see, I have got a lot of collection of problems that I am going to solve today. So see, at first, this question was asked in GATE. So what the question is asking you that a fluid has a kinematic viscosity of this amount, okay, meters square per second. So we know that this kinematic viscosity is symbolized with this mark, which is nu, and the dynamic viscosity is mu. It is also given Newton second per meter square is the standard unit, and meter square per second, this is also the standard unit. We already have discussed about kinematic viscosity and dynamic viscosity in the previous lectures. So if you didn't see that, go through and check it. So we have already got this two parameters given in our question, the kinematic viscosity and dynamic viscosity. So now you are asked to find the density of the fluid. So density of the fluid, we know the relation between the kinematic viscosity, dynamic viscosity, and density. And the relation is kinematic viscosity nu is equal to dynamic viscosity divided by rho. So you are already given the value of kinematic viscosity and dynamic viscosity. So you can very easily figure out the value for your density, which is rho, and it will have its unit as kg per meter cube. Now let's move on to our next problem. Let's solve this problem. This problem says that a plate 0.025 mm distant from a fixed plate. So this is the fixed plate, and the upper plate that you can see, this is actually a moving plate. Okay, moving plate. So the distance of the moving plate from the fixed plate is 0.025 mm, and it moves at 60 centimeter per second, and it requires a force of 2 Newton per unit area. So 2 Newton per meter square. See, Newton per meter square. As you know, what do you find from this? Newton per meter square is the unit of stress, right? So tau is F by A. So F is the meter square as its unit. So this is the unit, right? This is the unit of tau. So actually, indirectly, you are given the value of tau here. So this is nothing but your tau. Okay, so it requires a force of 2 Newton per unit area. So 2 Newton is the force. And as it is said that per unit area, that means per meter square. So this will become your stress. So to maintain this speed, okay, so to maintain which speed? To maintain the 60 centimeter per second speed of that upper plate. So now you are asked to find or determine the fluid viscosity between the plates. So now this is very easy. See, I'm writing the solution here. Okay, so you are already given the distance. So dy is given, dy is given as 0.025 mm. So just convert it into meters. So 0.025 into 10 raised to the power minus 3 meter. This is the dy, value of dy. So what is the value of u? So u is the speed of that upper plate, speed of the moving plate. So u is equal to 60 centimeter per second. So if you convert it into meter, you will end up getting 0.6 meter per second. Okay, so from here you can also find du. What is du? Du is equal to du, this is the change in speed. Du is the change in speed. So change in speed equal to final speed minus the initial speed. So here I can see the final speed is 60. So I assume that the initial speed was 0. Okay, as it has started its journey from 0. So 60 minus 0. Okay, so centimeter per second. So I will end up getting 0.6 meter per second as my value of the change in velocity. Change in velocity of the upper plate, upper moving plate, and apparently this is having the highest or maximum speed in this case. So after that, what I am given is tau. The value of tau is equal to given as 2 Newton per meter square. See, how did I understand this? That this is the value of the shear stress, right? How did I understand? I understood seeing the unit. The unit says 2 Newton per meter square, and Newton per meter square is the unit of the stress. So that's why I found that this is the stress. But why this is shear stress? Because the force which is required here, the force which is being applied here, this is the tangential force. This is the tangential force. So definitely due to the action of tangential force, I'll get tangential stress, which is tau. So now see, I know we have already derived this equation as well, which is tau is equal to mu du dy. Du dy is the velocity gradient, and our mu is the viscosity, or it can also be termed as dynamic viscosity or absolute viscosity. So this is what we are asked in the question. So now if I calculate it from here, mu is equal to tau over du dy, I will get the value of tau is 2. And what is the value of du dy? The value of du is 0.6, and the value of dy is 0.025 into 10 raised to the power minus 3. Okay, so tau divided by du dy. So everything is written carefully, and now I will see that I will end up getting the value as 8.33 into 10 raised to the power minus 5 Newton second per meter square. So this is the value. So in this problem, the value of dy was given, u, the speed of the upper plate was also given. I found the change in speed from there, and after that, it was a little bit tricky because it was given as 2 Newton per meter square, and by seeing the unit, I understood that this is the value of my shear stress, and after that, I just calculated using this very basic formula of dynamic viscosity. Now let's move on to our problem number 3, in which the statement says if the velocity distribution over a plate is given by u. Okay, just like this, you have a setup there, and the velocity distribution in this case given as 60 centimeter per second. But in our problem number 3, the velocity is given as a function of y. And what is y? Dy is the distance, the distance from the fixed plate to the upper plate. So the value is also given as y. See the value is given as the option. See, I'm making it. So this is my fixed plate. This is nothing but my fixed plate. Okay, and this is my moving plate, and the velocity of this plate is u, which is 2 by 3 minus 2 by 3 y minus y square. Okay, so the value of this plate is given as a function of y, and I am assuming that this is y, and determine the shear stress at y equal to 0 and y equal to 0.15 meters. So we have got two y at first y equal to 0 and then y equal to 0.15. So in both of the cases, we need to determine the value of the shear stresses, that means the value of tau, and take the dynamic viscosity of the fluid as 8.63 poises. Okay, so let's write down the solution. So solution. So the given parameters are at first u is equal to 2 by 3 y minus y square. So from here I can very easily find the value of du dy. As this is the velocity gradient, already I can I can differentiate this term of u by y. Okay, so du dy is going to be equal to d dy of 2 by 3 y minus y square. So I will end up getting, so if you just differentiate it, 2 by 3 minus 2y, 2 by 3 minus 2y. Okay, so this is the differentiation of u with respect to y. Okay, so this is a complete differentiation, it's not partial. After that, you can easily find the du dy at y equal to 0. What is this at y equal to 0? Because you are asked to find the tangential stress equal to what, right? This is the asked parameter. So how do you find that? Tau is equal to, sorry, tangential stress. So tangential stress is equal to mu into du dy. So you will need du dy. Okay, in du dy in two cases, in at y equal to 0 and at y equal to 0.15. So that's why I am at first calculating the value of du dy, or the velocity gradient, at y equal to 0. Okay, so this will give me du dy at y equal to 0 is equal to 2 by 3 minus 2 into 0. So I will get 2 by 3. Okay, so du dy at y equal to 0 is 2 by 3, right? And 2 by 3, if you just calculate it, you will get 0.067. So this is the value of du dy at y equal to 0. And what is the value of du dy at y equal to 0.15? So I will figure that out as well. Du dy 0.15 is equal to 2 by 3 minus 2 into 0.15. So if you just calculate this, you will end up getting 0.367. 3.67. So I have already found the desired parameters for tau du dy at two cases, y equal to 0 and y equal to 0.15. So now you need to find the value of mu. So mu in the SI unit. So 8.63 is already given as Poisses. So 8.63 divided by 10. If you just divide the value of Poisses by 10, you will get the value of mu, value of the viscosity in Newton second per meter square. So now I have already been able to calculate the all different values. So now I will calculate number one. I will calculate the shear stress at y is equal to 0. So shear stress at y is equal to 0. Shear stress at y equal to 0 will be tau at 0. Tau at y equal to 0 is equal to mu du dy at y equal to 0. So this will give you, mu is given as what? Mu is given as 0.863 and du dy is already calculated as 0.0667 at y equal to 0, right? So if you just calculate it, you will end up getting 0.5756 Newton per meter square. Newton per meter square will be the unit for your shear stress or stress, as stress is equal to force upon area. So force having Newton and area is having meter square. So already you are able to find the shear stress at y equal to 0. In the same fashion, I am writing is shear stress at y is equal to 0.15 at 0.15 is equal to mu du dy at 0.15 at y is equal to 0.15. So you will end up getting mu is 0.863 into the value of du dy at 0.15 is 0.367. So if you just calculate it, you will get 0.3167 Newton per meter square. So both of them are your answers. So in this problem, we were given the value of u. U is the velocity of the upper plate of the upper plate or the moving plate. Okay. So and the moving plate was at y distance from the fixed plate. Okay. So and y was given. So we found the velocity gradient du dy y, because du dy is the velocity gradient, and we can use it in order to find the tangential stress, because we know that the tangential stress in this case will be equal to mu, which is the dynamic viscosity, in d and into du dy, right? So and after that we just figured out the value of the velocity gradient and y equal to 0 and y equal to 0.15, because in both of the cases we have to find the value of the tangential stress. So we need to figure out the value for both of the cases, and after that we figured out the value of the shear stress at y equal to 0 and y equal to 0.15 just by using the formula. Okay, and in both of the cases the mu, the value of the dynamic viscosity, will remain constant. The value of the dynamic viscosity is 8.60, because for this entire fluid the value of mu is definitely constant, right? Because this is the proportionality constant, we already seen that. Okay, so I've already solved 3 different problems. So in the upcoming lectures we will solve many more problems. So till then, take care, goodbye, see you in the next lecture.